Hi learners! In today's video, you will learn what a dilation is. You will also gain knowledge of the different properties that are both observable and the not so obviously observable as dilation occurs. These properties will be unveiled and explained so that you will be able to apply these learnings in answering application problems on the topic. Strategies in analyzing and solving word problems related to the topic are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometric problems similar to these in the future. If your lesson is on dilation, or if you have an assignment on this topic, or if you're preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us start by describing what a dilation is. A dilation is a kind of transformation that is non-rigid. Recall that a rigid transformation is a type of transformation where there is no change in size and shape of the object after a transformation like translation, reflection, and rotation. Dilation, on the other hand, is a transformation where the size of the figure's image is different from the size of the pre-image, the original figure, hence the term non-rigid. The size of the image could be larger or smaller than the size of the pre-image after a dilation. Though the size is changed, the shape is retained. A dilation can be illustrated in this way, where triangle A prime, B prime, C prime, the image is larger than triangle ABC, the pre-image after a dilation, but the shape of the two are the same. Or it could be illustrated this way, where triangle X prime, Y prime, Z prime, the image is smaller than triangle XYZ, the pre-image after a dilation. Again, they are of the same shape. Thus, we can describe a dilation as a transformation that produces an image that is of the same shape but not of the same size as the pre-image. But how does a dilation really take place? Let us look at these learners. What did you observe? Correct. The pre-image was stretched from a fixed point, forming an image that is larger in size than the pre-image. How about this one? Right, here an image smaller than the pre-image is produced as the pre-image is made to shrink from a fixed point. This fixed point where the image is resized is called the center of dilation. You must have observed that the farther the image is from the center of dilation, the larger the image becomes. The nearer the image is from the center of dilation, the smaller the image is. Have you observed this, learners? The ratio of the size of the image to the size of the pre-image is the scale factor K. That is, K, the scale factor, equals the image size over the pre-image size. It describes how many times larger or smaller an image is to the pre-image. In this case, where the size of the image is twice as large as the pre-image, the scale factor K equals 2. On the other hand, where the size of the image is 1/2 the size of the pre-image, the scale factor K equals 1/2. You must have noticed also that when the scale factor is greater than 1, that is, when the image is larger than the pre-image is located between the center of dilation and the image. When the scale factor is less than 1, that is, when the image is smaller than the pre-image, the image is located between the center of dilation and the pre-image. Take note that when K is 1, there is no dilation that takes place, for at this point, the pre-image has the same size as the image. Remember that in dilation, a change in size occurs. I hope you're able to follow this, learners. For this video lesson, we will limit our discussion to positive K only. Okay, so the following are the other properties that are observable, though may not be obvious during dilation. Here, the corresponding angles are the same. This explains why the shape is retained during dilation. Also, the pre-image and the image are similar. This is because the shape is retained, but the size is changed during dilation. Another observable property is that the pre-image and the image are of the same orientation. Also, corresponding points remain on the same lines that are coming from the center of dilation. Another observable property is that corresponding sides of the image and the pre-image are parallel, and parallel lines remain to be parallel. Remembering these properties will help you analyze and answer math problems related to this topic with ease. Let us look at the sample problems here to check our understanding of the concepts. Sample problem 1, here is the problem. The figure shows line segment MN and point O that is not collinear with points M and N. So figure is given here. Suppose line segment M prime N prime is the image of line segment MN after a dilation with a scale factor of 0.75 centered at point O. Which statement best describes the position of line segment M prime N prime? Option A, line segment M prime N prime intersects line segment MN at one point but is not perpendicular to line segment MN. Option B, line segment M prime N prime lies on the same line as line segment MN. Option C, line segment M prime N prime is perpendicular to line segment MN. And option D, line segment M prime N prime is parallel to line segment MN. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, learners? You are correct. We're asked which statement best describes the position of the image of line segment M prime N prime after a dilation of line segment MN with a scale factor of 0.75 centered at point O. What are given? The problem tells us that line segment M prime N prime is the image formed after a dilation of line segment MN with a scale factor of 0.75 centered at point O. A figure is given. One strategy in answering this problem is to draw the image and to go over each option to see if the options correctly describes the drawing. The scale factor is 0.75. This is less than 1. What does this imply? Right, that the image is smaller. What else? That the image is between the center of dilation and the pre-image MN. Now, we have an idea where the image is located. When drawing a dilation, start by tracing lines coming from the center of dilation to the points on the pre-image. Next, make use of what is given in the problem. It says that the scale factor is 0.75. This means that the image is only 3/4 the length of the pre-image. In other words, the image is shorter. Now, we will position the length that is approximately 3/4 the length of the pre-image between the center of dilation and the pre-image. Remember that corresponding points, we will use the endpoints here, must be on the same line coming from the center of dilation. Here is now the drawing. We will now label the endpoints of the image as M' and N'. Using the drawing, we will go over the options and see which one is correct. Let's go. Option A, line segment M'N' intersects line segment MN at one point but is not perpendicular to line segment MN. Does line segment M'N' intersects line segment MN at one point? No. Okay, option B, line segment M'N' lies on the same line as segment MN. Does line segment M'N' lies on the same line as line segment MN? Okay, so obviously not. Okay, option C, line segment M'N' is perpendicular to line segment MN. Now, is line segment M'N' perpendicular to line segment MN? Again, no, it's not. Okay, option D, line segment M'N' is parallel to line segment MN. Is this statement true? So yes, line segment M'N' is parallel to line segment MN. So the answer is option D. That was easy, right? Okay, let us proceed to sample problem 2. Here is the problem. The image below will undergo a dilation centered at point G with a scale factor of 3. Which line will not be changed by the transformation? Select all that apply. Option A, line DF. Option B, line BA. Option C, line DG. Option D, line AE. Option E, line GE. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to determine which lines will not be changed by the dilation centered at point G with a scale factor of 3. What are given? We're given an image consisting of intersecting lines that will undergo a dilation centered at point G with a scale factor of 3. Okay, so the figure will undergo a dilation centered at point G. Where is this, learners? Okay, so it is here. It says that it will undergo a dilation with a scale factor of 3. What does it imply? You are right. The image will be 3 times larger than the pre-image. Take note that we are asked which lines will not be changed by the dilation. Let us try stretching the figure centered at point G and see what will happen. What did you observe, learners? Which lines did not change by the dilation? Is it line DF? Let us locate line DF. DF is changed to D'F'. Do you see this, learners? So no, the line changed. Is it line BA? Let us locate line BA. BA is changed to B'A'. Do you see this, learners? So no, the line changed. Is it line DG? Let us locate line DG. Look at these, learners. Line DG is still the same line. So yes, line DG did not change. Now is it line AE? Let us locate line AE. AE is changed to A'E', so no, the line is changed. Is it line GE? Let us locate line GE. Look at these, learners. Line GE, still the same line. So yes, line GE did not change. So what are our answers here? Okay, so the answers are option C and option E. Now, what do you think is the reason why line DG and line GE did not change? You are correct, learners. Line DG and line GE are passing through the center of dilation. That is why they are not changed during dilation. The other lines are not passing through the center of dilation. That's why they change. So remember this, learners. Lines passing through the center of dilation will not change during dilation. This is a property of dilation. Okay, so I hope you're able to follow it, learners. We move on to sample problem 3. Here's the problem. Below, EF is dilated to form E prime F prime by a scale factor of 25 centered at G. A figure is given. Which statement will always be true? Option A, the measure of GE is equal to the measure of E prime. Option B, the measure of EF is equal to the measure of E prime F prime. Option C, line segment GF is parallel the line segment GE. Option D, line segment EF is parallel the line segment E prime F prime. And option E, 25 times the measure of E prime F prime equals the measure of EF. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. What are we looking for, learners? You are correct. We are to determine which statement about the dilation of EF by a scale factor of 25 centered at G is true. What are given? We're given an image of EF dilated to form E prime F prime by a scale factor of 25 centered at G. Again, a figure is given here. Okay, so all that we need to do is to examine its option and verify if the statement is true or not by using the figure that is given. Let's go. Let us look at option A, which says the measure of GE equals the measure of E prime. Where are these, learners? Okay, so G is here and E prime is here. Are they equal? We see that the statement is not true. They are not equal. Okay, so let us look at option B. The measure of EF is equal to the measure of E prime F prime. Okay, so EF is here and E prime F prime is here. Are they equal? We again see that the statement is not true. They are not equal. Let us look at option C. Line segment GF is parallel line segment GE. Let us locate again where these are. GF is here and GE is here. Are they parallel? No, they're not. Now let us look at option D. Line segment EF is parallel line segment E prime F prime. Where are these, learners? Okay, so these segments are here. Are they parallel? Yes, the statement is true. Segment EF is parallel segment E prime F prime. Now let us finally look at option E, which states that 25 times the measure of E prime F prime is equal to the measure of EF. What does this mean, learners? Right? It means that EF is 25 times longer than E prime F prime. Is this true? Let us verify this on the figure. The statement is false. The figure shows us that E prime F prime is longer than EF. So, what is our answer here? Right, the answer is option D. Okay, so that was easy. I hope you were able to acquire lots of learnings in today's video. Let us summarize what we have learned in today's video. We have learned that, first, a dilation is a transformation that produces an image that is of the same shape but not of the same size as the pre-image. The pre-image and the image are similar. Second, the fixed point where the image is resized in dilation is called the center of dilation. Third, the ratio of the size of the image to the size of the pre-image is the scale factor K. That is, K is equal to the image size over the size of the pre-image. Fourth, when the scale factor is greater than 1, the image is larger than the pre-image, and the pre-image is located between the center of dilation and the image. Fifth, when the scale factor is less than 1, the image is smaller than the pre-image, and the image is between the center of dilation and the pre-image. Sixth, the following are the other properties that are observable, though may not be obvious during dilation. A, corresponding angles are the same. B, the pre-image and the image are similar. C, the pre-image and the image are of the same orientation. D, corresponding points remain on the same lines that are coming from the center of dilation. E, corresponding sides of the image and the pre-image are parallel, and parallel lines remain to be parallel. Seventh, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. Eighth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.